This video illustrates the redirection within a bash shell. Each command or program has an input stdin, which is file number 0, an output stdout, which is file number 1, and an output for errors, which is stderr or file number 2. There are 4 redirection symbols. The greater than, using a 1 greater than, we're redirecting stdout, and if you only put a single greater than, it will overwrite what data is in that file. But if you put 2 greater thans, it will append to an existing file. In both cases, if the file does not exist and you have permissions to create that file, the greater than signs will create the file specified. The 2 greater than will redirect stderr, appending if you do a 2 with 2 greater than signs. 0 less than will redirect the input from a file into the command. Since there's only one input, the less than sign implies that it is using or inputting to file 0. We'll also look at the effects of the pipe command. To start with, let's take a look at a simple command such as the echo command. In its base form, the echo command simply takes a string that is passed as an argument to the echo command, and it sends that string to stdout, as shown here. However, with using redirections, we can redirect greater than, meaning we're redirecting stdin. We could also put the 1 greater than, and we could put a file name here. We'll call it hello.out. Now, to view a file, we could use a couple of different commands. One command that's available to us is called the cat command. Now, cat actually stands for concatenate. And what it'll do is take as input arguments a whole bunch of files and then concatenate the contents of each file in order and send those out to stdout. So in this case, I'm going to pass the cat command the hello.out file as an argument, and it will read that file and send its contents back to stdout so that we can see what is in that file. Now, if we change this and we send another string into this file hello.out, and then we cat that file, we can see that the hello class was overwritten with our response from the goodbye. Again, using the 1 here is implied, so if we take the 1 out, we're still writing stdout into the file. Now, if I add 2 greater thans, we are appending the file. So using the cat command, we can see that in this case, up above, I had added to the file hello.out, or I had put in the file, I should say. I didn't really add to the file, but I'd put into the file goodbye class. And then I ran the command hello class with 2 greater thans, which will then add or append to the end of the file that string. So as you can see, by doing this, we get 2 strings in our file. Now we can continue adding the file like this. Now in this case, I was using the echo command, which just sends stdout, the string that's on the command line, to stdout. However, we can add the contents of any command that is run. So for instance, if we take the who command, we see that we have this user Lee logged on multiple times, and if we do true greater thans into the hello.out file and then we cat this file, we can see that here is the goodbye and the hello class and then the 3 lines from the output of the who command. So as you can see, we can add anything to this file. Any output of any command can be redirected into a file and be saved for later. Now, looking at the errors, let's take a command like the copy command. If I was to copy the file /etc/host to my present location, okay, as you can see, we actually see no output from this command. The reason for that is the copy command did as it was instructed, and it went to the etc directory and copied the host file. Using the ls command to list that file, we can see that there is a file now listed in my present working directory, which is owned by the current user Lee, and has that file. However, if I was to copy a file /muddy river, okay, you might suspect that maybe that file doesn't really exist, which it doesn't. So if I try to copy this and put it in over top of the host file, which I had just copied before, I get cannot stat /muddy river, meaning I cannot find any information about it, so therefore the copy command cannot copy it. Now, as you expect, this is an error message, and therefore comes out the output standard error or file number 2. So using this, I could add it using a 2 greater than, and if I put 2 graders, I can append. In this case, I'm going to go ahead and append it to my old file hello.out, and as you can see now, what I have done is when I ran this command, we did not see any output or errors, but when I view the hello.out file, you can see that I added this error message to this hello.out file. Okay. Similarly, if we took a command such as the ls-l command, and I did an ls-l on the etc host file, and I do an ls-l on my muddy river file, and I'll do an ls-l on /bin/bash. Okay. What you will see here is that we get the error message from the muddy river not existing. However, note that the ls command did work. It did give us a response. It shows us the ls of the bin bash, and it shows us the ls of the etc host file. Now the order of it is in alphabetical order based on file names, which is why the bin bash showed up first, even though it was last in the list. But I do want to make a special note here that the ls command did work. It performed, or at least attempted to perform, the ls-l on each file, and when it found a file that it couldn't do an ls on, we got an error message. When it found a file that it could do the ls on, then we get the contents of, or the ls-l of that file. Using this, we can now redirect the output into ls.out and the errors into ls.err. As you can see, looking at this, we get no output to the screen. but we now have two files that begin with ls. We have an ls.err and an ls.out, and catting those, we can see that the contents in the error file is, of course, our no such file or directory, and the contents of the ls.out are just the two files that did exist. Okay. Now, sometimes we know that we might get some error messages such as no such file or directory or a permission denied, and instead of redirecting that error into a file that's going to be sitting on our hard drive, there's a special file in the system called /dev/null, and this is just kind of like a trash can, but basically if we do a to greater than dev null /dev/null, we are saying just take this and throw it away. I don't want to see it. I don't really care. I probably suspect that I'm going to get them, but there's nothing I can do about those errors, so I just don't even want to look at them. Okay. All right. Also, we can take output, such as like if we run the output of the who command, you see we get information about users who are currently logged on. Now let's say I want to look at the users who have a defined terminal. If you notice this second column here, we have :0, which just indicates a display that they're logged into, and then PTS indicates a terminal window or a shell. So you see this user Lee has two terminal windows, a 1 and a 3. And so using the grep command, I can search for the terminal PTS. The PTS indicates a pseudo terminal or a network type connection, in this case through the graphical interface. But taking the output of the who command, I'm going to use the pipe symbol, which is the vertical bar, usually right above the enter key on most keyboards, although some keyboards, such as laptop keyboards, do move that around. And I'm going to pipe the output of the who command into the grep command. And if you remember, the grep command is kind of like the grab command, and it says go out and grab all the lines that match whatever. In this case, whatever is going to be PTS. And so what I did was I took this entire contents from the output of the who command and searched through it using the grep command and grabbed only the lines that contained the PTS reference to them. In this case, the pseudo terminal references 1 and 3. Okay. We can do this to filter out or make the computer search for the matches. This is really useful when we have many lines of information coming out of a command. And instead of trying to strain your eyes and find all the relevant information, you can make use of the grep command to do this. Okay. Also, I want to note that the output of the who command, again, is being redirected into stdin of the grep command. So output of who was input into stdin of the grep command. However, the output of the grep command is going to stdout, which by default is my terminal. But if I ran this command and then redirected with a single greater than into my hello.out file, then we can see here are the two lines from the output of the who command filtered through the grep, so it shows only the matches to the PTS, and that is all stored in hello.out. Notice that all that stuff that was in my hello.out above is gone now because I put a single greater than, which overwrote all information that was currently in there. Finally, let's take a look at the output of standard Uh, we'll take a look at the output of standard, or the input stdin. Okay. To do this, I'm going to create a quick shell script that's going to echo out just a couple of lines. Please enter your first name and please enter your last name. And in between these, I'm going to use the read statement to read in from the command line some variables here. And then we're going to just say hello $first, $last. So in this case, the read statement is going to read from stdin, which is by default the keyboard, and it's going to read in and store in a variable first, whatever is typed there. Then it's going to read in the from stdin again and put that in the variable last. Okay. Now, since this is a shell script, we're going to have to give it execute permissions, and then I'm just going to execute it. Okay. And it says, okay, please enter your first name. Please enter your last name. And then, as you can see, it says, oh, hello, Richard Hartman, because that's what I typed in there. Now, using this, I show you how we can automate tasks, because if we know how this script is going to be asking for information, we can store that information ahead of time into a text file using redirection. In this case, I'm simply going to use the echo command, and I'm going to echo in Tom into the file. I'll call it name.dat, and I'm going to echo Sawyer with two greater thans into the name.dat. Okay, now again, this is just a data file holding in the information. In this case, we got Tom Sawyer. And now I'm going to run the command, and I'm going to redirect. Notice how the first thing on the command line is the command, and in this case the less than is pointing in towards the command, and then I'm going to put a data file, name.dat. So in this case, you see we got, okay, please enter your first name, please enter your last name, we're put on the same line, and then we get hello Tom Sawyer printed out on a line itself. Okay, so you can see how using this script we can store information inside of a data file, and then instead of you typing that information in each time, you just run the command and shove in the data using the less than. So instead of it coming in from the keyboard, which is the default stdin, it's coming from a data file where it was previously stored on the hard drive. Okay. Alright, so as we saw, this video illustrated the use of redirection within a bash shell.